We are continuing part 4 on slide 30 with figure 7.9, and it deals with the long run average and marginal cost curves. Now, if you have a look at these two curves, we've got on our vertical axis the cost in dollars per unit of output, and on your horizontal axis, you have output. So the blue line represents your long run average cost curve, and the magenta line represents your long run marginal cost curve. At point A, you can see that these two curves intersect, and they intersect at the minimum point of the long run average cost curve. So that is where they intersect. Now we can see that for output levels, in this region over here, before the intersection of your long run marginal cost and long run average cost, we have a scenario where the long run average cost is declining or falling. And while your long run average cost is declining, you find that your long run marginal cost lies below this curve. Thereafter, they intersect at the minimum point of this curve, and then you find that your long run average costs begin to increase for higher output levels, and then your long run marginal cost lies above this curve. So in the region where this curve is increasing, your long run marginal cost lies above it, and for output levels where your long run average cost is declining, your long run marginal cost lies below it. Now, very important concepts that we need to understand is economies of scale and diseconomies of scale. And this differs to returns to scale. Now, with economies of scale, you find that as output increases, the firm's average cost of producing that output is likely to decline. So think about that first part of the curve. As the average cost was declining, that was as output was increasing, and that occurred up to a point. So this represents economies of scale. Now, this can happen for a number of reasons, but some of the obvious reasons could be that as a firm operates on a larger scale, think about a larger factory that could have workers specializing in particular activities, and that could result in it being more productive as opposed to maybe one worker doing multiple jobs. With a larger scale, workers can in fact specialize in activities. And the greater scale can also provide for more flexibility. So you can find that managers can organize the production process more effectively. And another obvious reason could be that larger firms can acquire some of the inputs at a lower cost because they're able to purchase in bulk in large quantities, so they can negotiate better prices. So that could affect the mix of inputs, and that could, of course, affect their cost and result in lower cost inputs. Now, it is also possible that the average cost of production can increase with output as output increases. And there are again reasons for this potential change. So you know that in the short run, you find that your capital equipment, like your machinery or the space that you're using, is fixed. So although you may expand your output or increase your output, you can't change that fixed input initially. So hence workers could get in each other's way and they can't necessarily do their jobs properly. Also, managing a bigger firm can become quite complicated, managing complex tasks, etc. And also, with the issue of buying bulk, if you find that your input supplies are limited, that could result in prices being pushed up. So then you may lose that advantage of buying in bulk at a lower price for those particular inputs if there are limited supplies. Now, if you want to look at the size or the scale of an operation and the costs when the proportions or the combinations of labor and capital change, then that expansion path that you saw in figure 7.6, which was a straight line, is no longer straight. Then we need to use different concepts. And the concepts we use are that of economies of scale and diseconomies of scale. Now, economies of scale describe a situation where output can be doubled for less than a doubling of cost. Okay, diseconomies of scale is a situation where you can have a doubling of output, but it requires a more than doubling of cost. It must be noted that there is a difference to returns to scale that you dealt with in chapter 6 to the concept of economies of scale. Remember, returns to scale relates inputs to output. Here, with economies of scale, we're looking at output and cost. So, if we look at this block, we see an example of what increasing returns to scale would imply. So, increasing returns to scale is a situation where output more than doubles when the quantities of all inputs are doubled. So, you double your inputs, all inputs, labor and capital, and output more than doubles, right? Whereas with economies of scale, there is a doubling of output that requires a less than doubling of cost. So here we're relating it to the cost of those inputs. A firm could, for instance, experience increasing returns to scale and economies of scale. Now, economies of scale are measured in terms of a cost output elasticity. So, E with the subscript C, it refers to the cost output elasticity. Don't confuse this with cross elasticity, right? So, to measure economies of scale using this cost output elasticity, it is going to be given by the percentage change in the cost of production if there is a 1% increase in output. If we relate this cost output elasticity to your normal measures of cost, which you are familiar with, such as marginal cost and average cost, we can rewrite this equation as your cost output elasticity is equal to your marginal cost over your average cost. So, how would you interpret this cost output elasticity coefficient if you were given this coefficient? So if your cost output elasticity was equal to 1, that would occur where marginal cost and average cost are equal to each other. And that is a scenario where your cost increase proportionately to output. And if your cost output elasticity was less than 1, then you'd have a scenario where your marginal cost is less than average cost. So there you have economies of scale. And lastly, if your cost output elasticity was greater than 1, then that would occur where marginal cost was greater than average cost. And that is a scenario of diseconomies of scale. In figure 7.11, we can see the relationship between our short run and long run cost curves. So let's go back to that printing shop example. Now imagine you were to consider three different shop sizes. And if you were to expect an output of, let's say, Q0, then it would make sense for you to go for the smallest shop size. So here we have three different shop sizes. This represents the smallest shop size. This would represent the average cost of a medium shop size, and this represents the average cost of the largest shop size. So if you expected your output to be Q0, it would make sense to have the smallest shop size, and this would reflect your short run average cost for that shop, and the cost for that output would be $8. Now, if you were to then decide to produce at Q1, which is an expansion in terms of output, but remember you chose to have the smaller shop size, you would still find that you are on the short run average cost curve, and your cost in terms of dollars per unit of output would still be $8. However, if you decided to go with a medium or middle sized print shop and produce Q1, so this is the short run average cost for a medium sized shop, for instance, then your short run average cost is $10 for that output Q1. And that would not be ideal because it could have been $8 if you had gone with the smaller sized shop, for instance. However, if you are expecting to produce an output of Q2, then going with your medium sized print shop would make sense. And likewise, if you were expecting an output of Q3, then going with the largest size print shop would also make sense. So it really does depend on what your expectations of output would be, particularly in the short run, because of your short run average cost curves. And ultimately, the idea is to minimize those costs. Now, remember in the short run, you can't just make changes to the shop size, and that is why it is important to choose the correct shop size. Whereas in the long run, you know that all inputs can vary, so the shop size can change, and the choice will always minimize average cost. We can see that our long run average cost curve, which is this purple curve, it is the envelope of all these short run average cost curves. So your long run average cost curve will always envelope these short run average cost curves. In this portion of your long run average cost curve, we see economies of scale in this downward sloping portion. And then as output increases, we see diseconomies of scale. We also have with economies and diseconomies of scale, we find that the minimum points of these short run average cost curves do not lie perfectly on this long run average cost curve. We will continue section 7.5 in a final short video. So I will conclude here for now.